as more and more computers are built into everyday objects, our goal is for these to be invisible and to be so easy to use that you don't even realize you're using a computer. But how are we going to interact with all these computers? Obviously, we don't want hundreds of keyboards everywhere. Well, let's start by seeing what happens when we build a computer into a common object such as a table. And for this, I'll need a volunteer. Let's take somebody from this side. I think you seem very keen. Why don't you come on down? Yes, you. Come on. Right, so just come and stand over there. All right, so if you'd like to stand there. And what's your name?
Emily.
Emily. Right, Emily, what I'd like you to do is just to take the fingers and thumbs of one hand and just place it on this table and sweep it around and see what happens. Isn't that nice?
Yeah.
Okay, let me show you something else then. So this is a little painting game. So what I'm going to do is select a colour for you. In fact, let's do this. Okay, now take fingers and thumbs of both hands, put them on the surface and just try doing a little bit of painting for me. That's excellent. So we can see that this is a touch-sensitive screen, but it's a special kind of touch-sensitive screen because it can detect touch from multiple fingers at the same time. We call it a multi-touch display. But as well as detecting touch from fingers, it can also detect the presence of physical objects. So here I have what look like ordinary little squares of glass. So you can see it's just completely transparent. But if I put this on the table, we'll see something interesting happening. It becomes a little piece of a jigsaw puzzle, but a rather unusual one because it's a video jigsaw puzzle. So here are some more pieces of the video jigsaw. So, Emily, would you like to have a little go? And we'll see if we can assemble this jigsaw. And see if you can fit some pieces together. That's good. And if you want to play with this video jigsaw, you can find a simulation of it on the website which accompanies this year's Christmas lectures. That's good. Try it around. That's it. And slide the last piece in.
You've completed the puzzle.
Well done. Excellent. Thank you very much. Okay, that was impressive. So, how does this actually work? Well, inside the box here we have a projector, and the projector is projecting images onto the screen, and that's all fairly standard. But also inside the box are some special lights that produce infrared light, and that's light that can't be seen by the human eye, but there's a camera in there which can detect infrared. And it uses an effect that you may already have seen before, and it's this. What I have here is a piece of the plastic that's used to make that screen. I'm just going to hold it up against some white light, and you'll see that if I put my hand behind it, all you can see is a sort of vague shadow of my hand. But if I touch the plastic, there, you can see my fingertips very clearly. And so the infrared camera is able to detect those. And those video jigsaw pieces, inside each of these is a special little code that can only be seen with infrared light. And each piece has its own code, so the computer knows which piece is which and which way up it goes. Now, the most common form of computer display these days, by far, is called the liquid crystal display, or the LCD. And in fact, this screen behind me is an example of an LCD screen. So how does a liquid crystal display work? Well, we can find out by doing an experiment, and for this I'll need a volunteer. So let me take somebody from this side. Okay, should we have you? Yes? No? No, in front. Yes, you. Come on. Come and stand here. And what's your name?
My name's Sarah.
Sarah. All right, Sarah. Now, the other thing I'm going to need is a nice, cool, trendy pair of sunglasses. Anybody got some cool shades? Hey, Andy, can I borrow the lenses from your sunglasses? Okay, thanks, Andy. Brilliant. Okay. don't look so cool now, do you? So these are the lenses from a pair of sunglasses. What I'd like you to do is if you could just look straight into that camera for me and just hold that in front of your face like that, okay? I'll just tilt it forward slightly so we get a reflection. That's good. Okay, so we can see that this is, you're making your face just slightly darker because of the dark plastic. And if I put another one in front, we'll see it doesn't really make very much difference. But now look what happens if I rotate this through 90 degrees. And if I carry on rotating, so that blocks the light, and if I carry on rotating, the light gets through again. Okay, now when you all came in this evening, you should have received some little blue envelopes. If you'd like to open those blue envelopes, and inside you'll find two little plastic squares. Now those little plastic squares are made of the same material as these sunglasses. So if you hold one of them in front of the other, and just look at the white screen up there, when you rotate them, you'll see that they first of all block out the light, and if you keep rotating, you'll be able to see the light again. Okay, so this is an amazing effect, but what's it got to do with liquid crystal displays? Well, if I take one of these lenses and I hold it up in front of this display, if I rotate the lens, you'll see again the display goes dark. So that's an amazing effect, but what's actually going on there? Well, if you'd like to just come over here with me, we're going to do another little experiment. If you'd like to come and stand about there. So we have to understand why light gets blocked when we rotate those polarizers. Now, light is a kind of wave. We call it an electromagnetic wave, and this machine will simulate wave motion. So what I'd like you to do is just crouch down here with me. All I want you to do is to move this up and down nice and slowly. Nice, big, slow movements. You got that? Keep hold of it. Okay? Keep going. Nice, big, slow movements. Okay, and that's sending a wave down the machine that's a bit like a light wave. All right. Now what I have here are some models of polarizers. Thank you very much. These are just sheets of plastic with slots cut into them. So I'm just going to place these over the machine like this. One there and one there. And notice they have the same orientation. They're both vertical. Okay, if you'd like to send a wave down the machine then, please. And that wave is passing through the first polarizer and then through the second polarizer. That's it. Nice, keep going. Nice, big, sweeping movement. So the waves are going all the way down to the end. Okay, just stop for a moment. What I'm going to do now is take one of these polarizers and rotate it through 90 degrees and then put it back again. So if you'd like to send another wave down the machine. So again, the wave is passing through the first polarizer, but this time it's getting blocked. So the wave doesn't make it all the way to the end of the machine. And that's what's going on with those plastic polarizers. Okay, thank you very much. So we've seen how polarizers work, but how can we use polarizers to make a display? Well, I'm going to take these plastic polarizers and mount them in these stands at right angles to each other, so the light is blocked. That's good. Here I have a box containing sugar solution. It's just ordinary table sugar dissolved in water. Let's see what happens when we slide this in between those crossed polarizers. Okay, so it now allows light to get through. What's happening is that the sugar molecules are rotating the direction of polarization. So the light passes through the first polarizer, is rotated, and can then pass through the second polarizer. Okay, you can take that out now, thank you. Now, if we're to use that to make a display, we need some way of controlling that rotation electrically. And we can do that like this. I have here two pieces of glass. They've been covered in some transparent electrodes, and then sandwiched between the glass is special material called liquid crystal. And I have another one of these here mounted in a stand. And on the other side of the stand, you can see we've attached some wires and we've connected it through to a power supply. So let's see what happens when we place this liquid crystal between the two polarizers. So again, we see it allows light to go through. The liquid crystal is rotating the direction of polarization of light. Now let's see what happens when we apply a voltage between those two sheets of glass. Is that nice? So what's happening there is that the liquid crystal molecules are normally twisted, and that's what causes this rotation of polarization. But when we apply a voltage, the crystals untwist and they no longer rotate the direction of polarization, and therefore the light is blocked by the second polarizer. And if I take the display out, I'm not going to switch it off, I'm just going to slide it out, and you'll see without the polarizers it just looks like a plain piece of glass. So we've seen how to control the level of white light getting through a screen. But how can we use this to produce a full colour display? Well, in front of this liquid crystal panel, we've mounted a lens, and if we can bring up a white light display on the screen and then zoom in on this region, we can just see some little squares. If we can bring up a magnification of that on the screen itself, so we can see that the screen is made of tiny little squares, and they're different colours. Some are red, some are green, and some are blue. Now this makes use of an important property of human vision, and to demonstrate this I'll need a volunteer. Who'd like to volunteer? Shall we have you? Yes, you. Really is you. If you'd like to come and stand round here. And what's your name?
Hugh.
Hugh. Okay, Hugh, what I'd like you to do is take this red slider and just slide it up to the top there for me. That's good. And on the screen up there we can see it's brought up some red light. Okay? Do the same thing with the green slider. Bring that one up to the top. That's brought up some green light. And you can see where the green and the red light overlap, it makes yellow. Okay, try taking the green slider back down to the bottom. That's good. And now bring up the blue slider. Okay, so we now have a mixture of red and blue, and where they overlap, we get a purpley colour. That's called magenta. Okay, let's bring up the green slider to the top now. So we've got red and blue and green. That's it, all the way to the top. And now, where the red and the green and the blue overlap, we get white light. And in fact, we can make any colour we like by taking the right mixture of red and green and blue. And we do this on a liquid crystal display by having little red, green and blue filters in front of each of those pixels. Of course, when we stand back from the display, we don't see the little pixels. Our eye blends it all together into one colour. Okay, thank you very much. So we've seen that liquid crystal displays work by sending light through crossed polarizers, and they use liquid crystals to control the amount of light that gets transmitted. Now, a disadvantage of this way of making a display is that it wastes a lot of light in the polarizers, in the filters, and also in the dark pixels. Now, a few years ago, it was discovered that certain plastics can actually emit light when you apply a voltage to them. They're called organic light-emitting diodes. And I have a display here that's made from this material. And what's interesting about it is that it just looks like a transparent piece of plastic, and it's completely flexible. But you'll see, if I apply a voltage to it, it emits light. And I can even flex the display while it's working. Another interesting thing about this kind of display is that it can be made by a process that's very much like an inkjet printer. And in the future, that may allow us to print displays onto things like boxes or even onto clothing, T-shirts and that sort of thing. So all the displays that we've seen so far are two-dimensional. And of course, they produce two-dimensional images. But the real world is three-dimensional. Can we produce a display that can produce three-dimensional images? Well, to find out, join me after the break.